Hello everyone. Today our topic is comparative study of solid, liquid and gases. So in the previous video we had discussed about the solid state and the liquid state separately, right? Now before discussing the gaseous state, this is the best way to study the solid, liquid and gases. इस तरीके से आपको properties बहुत clearly याद भी हो जाएंगे. So if here I have made a column so that you get memorized. You can write it also. एकदम simple way, एकदम simple और convenient way में मैंने बताया ये solid, liquid और gas के बारे में कि कैसे हम इसको study कर सकते हैं, right? So let's start. First parameter, already in lecture 1 and 2 we had discussed that the first parameter is what? Shape and volume. So when we are discussing about the shape and volume, the solids have fixed shape and fixed volume. Liquids have fixed volume but not fixed shape, right? And the gases neither have fixed volume nor fixed shape. Got it? So this is new for you. Gaseous state is new for you. So gases has neither fixed shape nor fixed volume. Right. Now the shape and volume will be more clearly when we see this particular arrangement of the states of matter. This is the arrangement of particle in solid state, this is in liquid state and this is in gaseous state. Right. So you can see here in solids the particles are very closely arranged. Right. Very tightly packed, very closely arranged. In liquid the particles are little bit far apart. Means what? The interparticle space is somewhat more than the solids, right? But in gaseous state you can see I just use red color to show the interparticle space so that it will be clear to you, right? This circle represents the particles and this red color represents the interparticle spaces. So the interparticle spaces in between the gaseous particles are very, very large. Got it? So these are the particle arrangement of solid, liquid and gas. Now a question can come in your mind. Why we always represent a particle with the help of circle? Right? The answer is very clear. Actually, it is experimentally determined that the shape of particle, that is atom, is spherical or circular. That's why we use circle to denote the particle. Right? So you can see here the particular arrangement of solid, liquid and gases, right? So since solids have compact arrangement, solids are tightly packed, that's why their shape and volume both are fixed. Got it? Similarly, in liquids there are somewhat space, interparticle space is more than the solids, that's why their volume is fixed but their shape is not fixed. Clearly? But in gaseous state, you can see it clearly that there is large interparticle space, right? There is large interparticle space which shows that it has neither fixed volume nor fixed shape. Clear? So this is the first parameters, or we can say the first property on the basis of which we can differentiate between solid, liquid and gases. Clear? Now the second is interparticle space, right? So interparticle space in solid, liquid, gases are minimum in solids. You can see here the red part is very less. So this red part is interparticle space, right? So this red part is very less. So the interparticle space is minimum in solid state, okay? And this is more in liquids. We can say it is more than the solids, right? Here you can see the red part is more. That's why we can say that the interparticle space is more than solids. Clear? Now when we are talking about the gaseous state have many interparticle spaces. So here we have written maximum. So the interparticle space is maximum in the case of gaseous state. Right? Now the third parameter which we are having is force of attraction. Already you know force of attraction is what? The binding force which holds two particles together. So the force of attraction in solid state is maximum. Since the particles are very closely arranged, very tightly packed, so the force of attraction is maximum in the case of solid state. It is less than solids. For liquid, it is less than the solids. In liquid states, the force of attraction is less than the solid states, right? And if we are talking about the gaseous state, the force of attraction is least, it is minimum, right? Why it is minimum? Since the particles are free to move, since the particles are far apart, right? So there is no any attractive force, there is very thin attractive force, very less attractive force which holds them together. That's why the force of attraction is minimum in the case of gaseous state. Clear? Now the next one is kinetic energy. Kinetic energy is what? The energy developed in a body due to its motion. So the kinetic energy of solid state is minimum. This is because there is less chances of movement of the particle. In the previous lecture, we had already discussed that since the particle of solid state just vibrate at their own position, so the kinetic energy is minimum, right? When we are talking about the liquid state, the kinetic energy is more than the solids. Clear? More than the solids. What does it mean? It means the particles have slight chances of the movement. Since the gap is more, so they can move from one space to other space. And since the movement is more, that's why the kinetic energy is also more than the solid states. When we are talking about the gaseous state, the kinetic energy of gaseous state is maximum, right? The kinetic energy of gaseous state is maximum. So we can say that the kinetic energy of solid state is minimum, liquid state is intermediate, and when we are talking about the gaseous state, it is maximum because of the maximum chances of movement of the particle. Now, if a question is asked, you are in standard 9, so don't expect this type of question that what is the kinetic energy of gaseous state or what can be the interparticle space of solid state, right? Your question will be always in the form of reasoning, right? So a question can be asked, why the kinetic energy of gaseous state is maximum? So your answer should be, the kinetic energy of gaseous state is maximum because of the more chances of movement of the particle. Since the interparticle space is more, that's why the chances of movement of particle is also more, and that's why the kinetic energy is maximum. Correct? Now, the next parameter which we are having is density. Right? What about the density of the three states of matter? So the density of solid state is maximum, which we have already discussed, and the density of liquid state is less than the solids, right? It is less than the solid state. It is because of the mass and the volume, right? Density always depends on two factors, masses and the volume. Clear? If mass is more, density is also more. If mass is less, density will also be less, right? Means what? Masses are directly proportional to the density. But if we are talking about the volume, it is inversely proportional to that of the volume. If volume is more, density will be less, and if volume is less, density will be more. So the density of solids is maximum among all the three states of matter. It is less than the solids in liquid states, and it is minimum in the gaseous state. And the very prominent reason behind it is the volume of gases are very large as compared to solids and liquids. So since the volume is very large, that's why the density is very low, because we know that density is inversely proportional to that of the volume. Correct? Now, the next factor, or we can say the next parameter, is rigidity. Rigidity means what? The object will retain its shape and size or not, right? So the rigidity of solids are very high. So solids are rigid in nature. Got it? But liquids and gases both are not rigid in nature. Clear? Then compressibility. Now this compressibility term is only for the gaseous particle. Right? Only the gaseous state of matter has the tendency to compress itself. We cannot compress liquid, we cannot compress the solids. Right? we can compress the liquid to certain extent due to the interparticle space present between the liquid particles. But since the practical use of compressibility of liquid is not there, so we are not supposed to compress the liquids also. That's why I have used the term incompressible here, right? Solids are incompressible because of the less interparticle space, least interparticle space actually. Liquids are also incompressible, but the gaseous are compressible. So do remember the term compressibility is only for the gaseous state, as the term rigidity is only for the solid state, right? So compressibility is only for the gaseous state. Gases can be compressed. When we increase the pressure of any gaseous state, it is compressed, right? It will compress and changes into other state, which is our next topic actually. So just do remember, if we want to compress the gaseous particle, we can compress it. Clear? So since the interparticle space is more, that's why the gases can be compressed easily. Clear? Now, when we are talking about the fluidity, the fluidity term is basically for the fluids. Now, what are fluids? A student asks, what are fluids? It's a general question. What are fluids? Okay. So, anything which can flow or which can blow, we can say, are called as fluids, right? So, fluidity is maximum in liquids and gases. Liquids can also flow, gases can also blow, right? So, they can flow, and that is again due to the large interparticle spaces, right? But when we are talking about the solid state, there is no fluidity for the solid state. So, if we summarize these points, shape and volume, interparticle space, force of attraction, kinetic energy, these are the main parameters which decides the three states of matter. This is the main differentiation criteria, we can say, between the solid, liquid and gas. Density, rigidity, compressibility and fluidity, these are somewhat less important, but you should keep in mind these factors are also responsible to categorize the states of matter into different categories, right? Now, I just suggest you to learn all the properties of solid, liquid, gas in this tabular form. You can see this tabular form, you can write it also. This is the best way to memorize the properties of solid, liquid and gas. Now, after the comparative study of solid, liquid and gas, we are having our next topic as diffusion, right? So, what is diffusion? Diffusion is actually spreading out of substances due to its motion, right? So, if anything moves and gets spreaded out, it is called as diffusion. For better understanding, you are having a second definition, that is intermixing of substances from higher concentration to that of the lower concentration is called as diffusion. So, when two substances get mixed with each other, and always the mixing will take place from higher concentration to that of the lower concentration, then it is called as diffusion, right? There is a very simple, I am just taking a very simple example. मान लो एक नदी जा रही है, ठीक है, उससे आपने एक स्ट्रीम कट किया है, तो हमेशा क्या होता है कि उस नदी में से वो स्ट्रीम पे पानी जाना शुरू हो जाता है. The reason behind it is, here in the river the concentration of water is more, right? And that side, in that stream, the concentration is low. That's why the water always flow from the river to that of the stream. Clear? Now, so intermixing of substances from higher concentration to that of the lower concentration is called as diffusion. Clear? Now the next point is rate of diffusion. So rate of diffusion increases with increase of the temperature. As we increases the temperature, the intermixing will be fast. The spreading out of the matter will be fast. So diffusion depends on the temperature. If temperature increases, rate of diffusion also increases. Therefore, we can decide by these 2 points that diffusion is maximum in gaseous state, right? Why it is so? Since we just talked about the intermixing of particle. So, when intermixing is possible? That is only possible when there is some interparticle space so that the other material can intermix, right? So, in gaseous state, the chances of intermixing is maximum due to the maximum interparticle spaces. Now, many reasoning question can be asked on the basis of diffusion, just like why we feel the smell, or we can sense the smell from our kitchen of any delicious food. That is due to the diffusion, right? Why we can feel the smell of incense stick, that is agarbatti, from one of the corner of our room. That is also due to the diffusion, because that fragrance, that smell get mixed in the air and we can sense it, right? So there are so many questions based on diffusion. So that's all for today. In the next lecture, we'll continue with the effect of temperature on the solid, liquid and the gaseous.